the modulus or remainder operator. The percent sign is the operator for remainder. So 6% 3 is taken to mean 6 mod 3 or 6 remainder 3. When you divide 6 by 3, what's the remainder? It's 0. So this evaluates to 0. 5 would give us 2. 5 mod 3 is 2. 2 mod 3. Well, anytime you have a number smaller than another number, print 79 mod that. Well, you take out all of these that you can from here, which would be none of them, and what's left would be 79. So therefore, 2 mod 3 is 2. 0 mod 3, similarly, 0 mod any number at all. The remainder after you divide 0 by 3 would be 0. So this is 0. Negative 4 mod 3. So what's going on there? So if we were to print negative 4 mod 3, we might think we're going to get 1. Might think we're going to get negative 1. Neither are true. We're going to wind up getting 2. The reason is with positive numbers, we're not truncating. We're going to, the remainder is the distance to the largest multiple of 3 that's no larger than this argument. The same thing holds true for negatives. So what is, think about the words carefully, the largest multiple of 3 that is no larger than negative 4? Well, that would be negative 6. And what's the distance from negative 4 to negative 6? And that would be 2. And that's where that 2 comes from. And so finally, if we were to take the mod of 0, well, to take the mod of 0, you have to, it's the remainder when you divide by 0, but you can't divide by 0. And so the mod of 0 crashes with a 0 division error. Now let's look at the second half of this. Rather than look at the examples, let's see if we can derive why. We said here that the modulus is the distance between this number and the largest multiple of this number that's no larger than this number. So let's see if we can construct that. And actually, I think the negative case here is probably a bad example for this pedagogically. So let's go with, say, 17 mod 5, which of course is 2. But let's reconstruct this a little bit. Let's go ahead and first say, what is 17 divided by 5? Well, it's 3.4. What is 17 integer divided by 5? And that's just 3. And then if I turn around and multiply back by 5, something interesting happens. Obviously, I'm going to get a multiple of 5 because this is an integer multiple of 5. But which multiple of 5? After we truncate it here and multiply back, we get the largest multiple of 5 that is no larger than 17. 15 is that largest multiple of 5, no larger than 17. Well, great. In order to get the modulus, we take the difference between 17 and this value, right? That would be 17 minus this, which gives us 2. So more generally, if I have, as we see in our example here, A and B, and I want to take A mod B. So say A is 17 and B is 5. A mod B is A minus A integer divide B times B. And once again, that's 2, because one last time, this does integer division with truncation, getting rid of the decimal part, so that when we multiply back, this highlighted portion is the largest multiple of B, no larger than A. And the difference is the modulus. And that is where this comes from. This statement is always true. That is definitional for what the modulus is.